All right, we're going to cover stoichiometry. Stoichiometry is the study of quantitative aspects of a chemical reaction. So it's kind of like quantitative means how much. So if I start with this much of a reactant, how much products will I get? So it's actually very useful when we're doing like lab chemistry, because we can actually determine how many grams we need to start with, how many grams we're going to end up with. Stoichiometry relies on the law of conservation of mass, and this is because the balancing of chemical equations, or the coefficients in a chemical equation, lead to what we call a molar ratio. Okay? Now, we'll talk more about that later. So, what is mole ratios? And so the mole ratios are always based off the coefficient. So the first question says, what is the mole ratio of CH4 to CO2? So you'll see that the coefficient for CH4 is 1, which means 1 mole of CH4 is used to produce 1 mole of CO2. So what's the mole ratio? It's 1 mole of CH4 to 1 mole of CO2. I got the ones from the coefficients. What about CH4 to H2O? So it's 1. What's the coefficient? 2. So 1 mole of CH4 to 2 moles of H2O. In the reaction, in this reaction that we've been talking about, how many moles of methane were used if 1 mole of water is produced? So what we're going to do is we're going to use our molar ratio. We want to go from water to methane, all right? So what's the molar ratio between water and methane? Well, for every 2 H2O, I should put moles, for every 2 moles of H2O, there is 1 mole of CH4. So this turns into the conversion factor. The molar ratio turns into the conversion factor. So I'm starting with 1 mole of water. So for every 2 moles of H2O, notice I put H2O on the bottom because I wanted to cross cancel. I have 1 mole of CH4. So 1 divided by 2 is 0.5 moles of CH4. So we're just using we're using dimensional analysis like we did last chapter, but our conversion factors, instead of like molar mass or Avogadro's number, we're using the molar ratio. Let's try this one. So it says if 2 moles of CH4 react, how many moles of H2O are produced? So what are we comparing? We want to figure out the ratio between CH4 and H2O. So for 1 mole of CH4, we get 2 moles of H2O. So if I start with 2 moles of CH4, I'm going to use this as my conversion factor. So for every 1 mole of CH4, I get 2 moles of H2O. So this gives me 4. 2 times 2 is 4, right? 4 moles of H2O. All right. This leads to our roadmap. So this is hopefully something that will help you as we go through these type of problems. So I'm going to put in this box. This is kind of like the area that people want to get into. And so this, we're going to say this is the balanced chemical equation. And from here, within this area, we can use what we call the molar ratio, just what we've been doing. But in order to use a molar ratio, we have to have moles. So in order to get into this box, you must convert to moles. So in here, to get into here is moles. So it's kind of like a ticket into this box, or a ticket into this area. We have to always convert to moles. So within here, since we're using what's called a molar ratio, we must have moles. All right, so let's take a look at out here, a lot of times you can start in grams with mass. Well, then you're going to have to convert, if you start out here, to mass. Or if you want to go back out to mass, then you have to convert And so a lot of times you use the molar mass. You'll have to convert back out to mass from moles. All right, so it says how many grams of water are produced if 1 mole of CH4 reacts? All right, so we want water, and we're starting with 1 mole of CH4. So let's think about the box. Here in the box we have molar ratio. All right, are we starting in the box or out of the box? Well, we're starting in the box. Why? Because we have moles. Once you realize you have moles, you're in the box. So we can use the molar ratio to convert to water. Now, I know we need grams of water, but before you can get grams of water, you actually have to convert to moles of water. So for every 1 mole of CH4, we have 2 moles of H2O. All right, so that's going to give us 2 moles of H2O. All right, so now I have 2 moles. So I now converted from moles of CH4, converted that into H2O using the molar ratio, right? But these are moles of H2O, so now I got to get out of this box. And I'm going to take 2 moles of H2O, and I want to convert that into grams. So I'm going to say 1 mole of H2O into 18.02 grams. So I technically have only 1 sig fig, so 2 times 18 is 36, but it should be 40 grams of H2O. Okay? So just remember, if you're in the box, what you're going to do is you just use the molar ratio as long as you have moles. And then if it asks for grams, then you have to convert out. There's actually a way to do this in one step. So I start with 1 mole of CH4. I'm going to go ahead and separate the two. So first I want to convert to water, moles of water. So for every 1 mole of CH4, I have 2 moles of H2O times, right? Because now I have moles of H2O. But do I want moles of H2O? I want H2O, that's good, but I need grams of H2O. So and 1 mole of H2O is 18.02 grams of H2O. So now you can kind of see, oh, all right, now my grams of H2O, that's what I want. I'm going to multiply everything. You should get 40 grams of H2O. Okay. All right, it says how many grams of oxygen are needed if 2 moles of CH4 reacts. So let's think about where we are. We're starting with 2 moles of CH4, which means if we're starting with moles, we're in the box. We're in the molar ratio box. We want to convert from CH4, right, to what? Well, we want grams of oxygen. Well, we first have to get to moles of oxygen. So let's convert to oxygen first, and then we're going to convert to grams of oxygen. All right, so I got 2 moles of CH4 times, now let's look at the molar ratio. Molar ratio of oxygen to CH4 is 2, right? So for every 1 mole of CH4, I need 2 moles of O2, right? 2 to 1. All right, so now if I cross cancel, I have moles of O2, but I want grams of O2. So I'm going to now go one more time. 1 mole of O2 gives you 32 grams of O2. So 2 times 2 times 32. 4 times 32 is like 128, right? But I only start with 1 sig fig, so actually it'll be 100 grams of O2. Okay? All right. The next one, it says how many moles of CH4 are required to combust 16.0 grams of O2? So we're starting with 16.0 grams of O2. Remember, here's our mole ratio box area, right? But here's the thing now. What are we starting with? We're starting with 16.0 grams of O2. It's out of the mole ratio box because 16.0 grams of O2 doesn't help us. We have to convert that to moles using molar mass, right? Then we'll have moles of O2, and then we can take that and convert that to moles of CH4. Right? So remember, you got to convert to moles if you want to get into the box. Now, the box helps you change between like different products or different reactants. So if I start with 16.0 grams of O2, so for every 2 O2, I have 1 CH4, right? So for every, oh, I'm sorry, I already skipped. We got grams, so what do we got to first do? We got to convert to moles. So I'm doing this first step here. So there are 32 grams of O2 and 1 mole of O2. Remember, O2 is diatomic. So that gets me moles of O2. All right, now we're in the club. We're in the box, right? And so we now know for every 2 moles of O2, I have 1 O2 and then 1 mole of CH4. So I'm going to take 16 divided by 32 and then divide that by another 2. Talking about 0.25. I need 3 sig figs, so 0.250 and moles of CH4. Okay. The key, I think, is to practice. So I have some practice here for you to take a look at. The first part is good, but I would make sure you start working through the other parts as well.